Okay, guys, today we are going to extend what we've talked about with essential questions 1 and 2 about interpreting data from the periodic table and about the subatomic particles, and kind of extend what we've done with tracing the atomic model through history. And we're going to talk about Bohr's model of the atom. And it allows us to draw the atom and show how many protons, neutrons, and electrons it has. Now, in 1913, this is when Niels Bohr was studying what happens to atoms when they are excited by heat or electricity. And what he discovered is that light is produced, and for multiple elements it's different colors. So like the barium is more purple, potassium is pink, sodium is kind of like a reddish, calcium is orange, and zinc is yellow. So he wanted to know why they produce different colors of light. And Rutherford's model could not explain why there were unique colors. Okay? So he wanted to kind of extend Rutherford's model. Okay, so write this down for me. Bohr's model is the planetary model of the atom, which says that electrons orbit the nucleus like the planets orbit the sun. So he is most well known for his planetary model, which again says that electrons orbit the nucleus just like planets orbit the sun, and they are on what we call orbitals. So they stay on that like circuit, okay? They stay on that same one, and then they can jump from orbital to orbital. So you'll see here in this picture, this is a model of carbon. So you've got your protons and neutrons in the nucleus, and then it shows the electrons in these rings. Now there are certain numbers of electrons that can be in each ring. So we're going to talk about how many. These are 2 other examples. This is potassium, so it shows the 19 protons and 20 neutrons in potassium. And then it shows the 19 electrons. Well, this is a Bohr model. Okay, this is a picture of one. We're going to do our own. And we're going to do a little bit, some of the more simple ones. And why that's not. Okay, well, this is supposed to be lower so you can't see it, but I want you to copy down this chart for me, please. In orbit, there's 3 orbits that we're going to do. Now there are more than 3, but we're going to max out at 3, okay, in this class. When you get to chemistry, you'll do more. But there are 3 orbits that we're going to talk about, and the maximum number of electrons in each one are 2, and then 8, and then 8. So in the first orbit, you can have 2 electrons. In the second orbit, you can have 8. And in the third orbit, you can have 8. Okay? So it's important that you know that what orbital can hold which number, because each orbit can hold a specific maximum number of electrons. Okay, so it will max out where you have to move on to the next one. Okay? Write down this last little bullet too. Electrons fill orbits closest to the nucleus first. So they're not going to like put 2 in the first one and then 2 in the second one and then jump to the third. It's going to put 2 in the first and then it's going to put 8 in the second, and then if it still has more, then it will move to the third orbital. So they're going to fill the orbits closest to the nucleus first. Okay, so guys, let's talk about fluorine. Can you find fluorine on your periodic table? Find fluorine on your periodic table. It is atomic number 9. Okay. So if fluorine is atomic number 9, then how many protons does fluorine have? 9. Good. And if it has 9 protons, how many electrons does it have? Great. And then the atomic mass for fluorine is 19, and we have 9 protons, so how many neutrons do we have? 19 minus 9, which is 10. Very good. So we are going to draw a circle. So I want you to add this to your notes. We're going to practice making a model, okay? I want you to draw a circle, and I want you to write 9p for 9 protons and 10n for 10 neutrons in the center of the circle. Okay? And that circle just represents your nucleus. Okay? Now, how many electrons can fit in the first orbit? 2. So you're going to draw the first orbit, and then we're going to draw in 2 electrons. Now, for future chemistry purposes, what we're going to do is we're going to draw all the electrons on one side, okay? And I'll show you what I mean when we get to the next orbital, but the way Mrs. Mathis teaches it when you get to chemistry, so I want to make sure that we do it the same way, okay? So if we have, how many total electrons do we need to draw? 9, right? 9 electrons. How many have we drawn already? 2. So now we need to draw 7 more, right? How many electrons can fit in orbit number 2? 8. So we're not going to need to draw that third orbital. We're not going to need it. Okay, so we're going to draw 7 more. Okay, so that we have 9. question so far? Okay, so let's try some more. The first one is hydrogen. So find hydrogen on your periodic table. Hydrogen is atomic number what? 1. Atomic number 1, right? So how many protons does hydrogen have? Just 1, right? It's atomic number 1. 1 proton. Take a look at hydrogen's mass. It is also 1. So in order to find the number of neutrons, we're going to subtract, right? Let's get this down before we start drawing. So protons is equal to 1. Neutrons, we're going to do 1 minus 1, which is 0. Okay, so hydrogen does not have any neutrons in the nucleus. And then how many electrons does hydrogen have? Just 1, right? Because it's the same as the atomic number. So 1 proton, 0 neutrons, 1 electron. So now let's draw the model. I'm just going to write 1p and 0n. Okay, 1 proton, no neutrons. And since we only have 1 electron, we're only going to need 1 orbit. Drawing the 1 electron. Okay. Okay, find boron on the periodic table. Boron is atomic number
5.
5. So how many protons does boron have? 5. What is the atomic mass of boron? 10. And then we are going to subtract what? Oh, we're going to round it up to 11. Yeah, we're going to round that up to 11. 10.8. So let's round that up to 11. And then we're going to subtract the number of protons, which is 5. So we're going to have 6 neutrons. And then how many electrons does boron have? 5, right? Okay. So draw your circle for your nucleus. We have 5 protons and 6 neutrons. How many electrons fit in orbit number 1? 2. So we're going to draw those 2 in. We're going to draw orbit number 2. We need 5 total, right? So how many do we need to draw in orbit number 2? 3 more. Okay. Questions on that? Okay, the last one we're going to do is magnesium. So go ahead and find magnesium on the periodic table. And on your paper, I want you to go ahead and find out how many protons, neutrons, and electrons we're going to have. And then go ahead and try to draw the model, and then I'll go over it. Okay, what's the atomic number for magnesium? The atomic number for magnesium?
12.
12, good. So how many protons does magnesium have?
12.
How many electrons does magnesium have?
12.
Okay. What's the atomic mass?
12.
Atomic mass? 24, good. And then we subtract 12, so how many neutrons do we have?
12.
Good, okay. So, draw your circle. You should have 12p and 12n for 12 protons, 12 neutrons. Now, we have 12 electrons, so we're going to draw orbit number 1. How many electrons go in orbit number
6.
1? 2. You only have 2 in the first one. 2, 8, and then 8. Okay? 2, 8, and then 8. So in orbit number 2, well, first of all, we needed 12 total, right? We've already done 2, so how many more are we going to have? How many more electrons do we need to draw? 10 more, because we have 12 total. We've already done 2. So now we're going to go ahead and put 8, because that's all that orbital 2 can hold. Okay, so I have 10 on here now. How many more do I still need? 2 more. So when I draw that third orbit, I need 2 more. So you should have 2, and then 8, and then 2 more. Okay, because remember, the max that electrons that they can hold is 2, 8, and then 8. And we're not going to do, so like this would take us through element 18, right? 2 plus 8 plus 8 is 18. So we're not going to do any of the elements higher than atomic number 18, which is argon. Okay? So we won't do any past argon, because that's when they start to get complicated. Okay? Alright, so back to our essential questions, because we're finishing up big idea 1, so let's kind of link all this together. Big idea 1 is atoms are the building blocks of matter. So we talked about all of the pieces of information that we can get about atoms. We talked about how to get data from the periodic table. Okay, so name, symbol, atomic number, atomic mass, protons, neutrons, and electrons. We talked about what the subatomic particles are, protons, neutrons, electrons, their charges, where they're found, and then we've traced the atomic model through history. And so today we took one of those scientists specifically and talked about his specific model of the atom in order to kind of extend what we've already done with subatomic particles. Okay?